vacuum system or not, to have the same toilet. So they approach me, how can we do this? What if I want a toilet of my own choice? So we say, well, you can do it, because what you do now is you use the Evac vacuum convert frame. What is it? Well, it's just exactly what I've been talking about. It's a frame that Evac have developed that will allow you to fit any toilet and convert your toilet into a vacuum toilet. And just like the traditional standard vacuum toilet, again, no electrics are required. So the frame sits in the wall void, and it's a very similar size to like a Geberit frame or a Dow system frame, sort of chest high, but without the cistern, because again, it's a direct feed. It's where the Evac components will sit. It does have some limitations compared to the standard vacuum toilet, whereas the standard vacuum toilet will only use 1.2 litres of water. If you're using an Evac toilet on the vacuum convert frame, 2.5. So still big water savings, and we can't quite lift as high. So 2.8 to 3 metres is the height that we can lift, as opposed to 5 metres with a standard vacuum toilet. And you do need to have that access panel there. It says there 555 by 383, because unless you have a toilet where you can have rear access, service corridors. So there are other options out there now available other than just the standard vacuum toilet that Evac operates. So let's have a quick overview on the toilets. Low flush volume, only 1.2 litres per flush. These points here takes in surrounding air and odours and dramatically increases ventilation. There is a video out on YouTube that has been tested by independents where they wanted to see, there was an old theory that if you flushed the toilet, would it contaminate your toothbrush? And what they did was they put the toilet under a backlight, filled the bowl with the UV fluid under a UV light, and flushed the toilet, and found that actually microbes of the toilet flush travelled up to 2 metres away. And even with the toilet seat down, that didn't make any difference, because you got such a blast from the agitation of the water coming into the bowl, and that air went somewhere and it blasted out the toilet seat and carried that contaminant with it. With a vacuum toilet, because it pulls in 60 to 70 litres of air, there is no airborne mist at all. And I do also have a video proving it where the vacuum toilet was tested. And we're looking at doing a hospital project where the patients had, unfortunately for them, chemotherapy. So they're all overcoming cancer and having cancer treatments, and their immunity systems are very low. And the trust are looking to use vacuum toilets, not because of a design, not because of flexibility, not because of water saving. They're all benefits they'll get, but actually looking at it from a health point of view and using the vacuum to draw in the airborne mist. Another little advantage of the vacuum technology. So let's have a quick overview of it. We can see the toilet on the right there, giving lots of airborne mist. The one on the left, nice and clean. Probably not 90% savings now, because toilet water flush has dropped, but nevertheless still significant savings and health benefits there. So I'm just going to stop at that point and just see if there's any questions on anything I've gone to before I move on to the next stage. Anyone have any more questions on the vacuum toilet system at all?
What about Asian toilets?
Yes, we do have a Eastern style toilet available. They call it the squatting toilet. There's a stainless steel version of it, and there's also a ceramic version of it. Evac are a worldwide company and sell a lot of these into the markets in China. So yes, there are vacuum versions of that available. The mechanism of the toilet is concealed underneath. It's almost like a shower tray and a toilet combined into two. Still has a flush button, still works in the same way, offering the same water savings. So yes, the Eastern version is available.
Oh, that's interesting to know in that, thanks.
There's not too much of a call of those in the UK just yet, but I do believe that will be something that will change. Whereas you have a bank of toilets and at the end you have a disabled toilet, I can see it becoming a disabled toilet, and an Eastern style squatting toilet may well become part, depending whereabouts in the country you are, but I can see that becoming a requirement. So how do we drain everything else? So I said that the vacuum toilet is the only specialist piece of sanitary ware needed, which is right, because if you're trading from a sink and a basin, a bidet, a washing machine, it goes via what we call an interface unit. And an interface unit, if you think of it in your head as like a pump where the water drains in by gravity, but it drains out by vacuum. So that's the interface between the two sort of systems, if you like. This means it can be anything standard, bath, basin, sanitary ware that you need. Now they come in various shapes and sizes, and the appropriate interface unit needed will be decided by me, because I'll know the flow rates and capacities of what you're delivering to me, and how often it's going to go off, that type of thing. They're very simple in their use. The one that's shown in the picture there is actually only a 150 millimeter cube, and its slang term that we call it is the ball in the box. The way that works is inside there is a ball. The right hand connection you can see is the outlet there. The lower one is the outlet, and that would be under a constant vacuum. And the plastic ball, which is inside that unit, is sucked against that nozzle, or sucked against a nozzle that sits on the other side of that outlet, because vacuum's there. As water flows into the box through the inlet that you can see on the left-hand side, the higher one, eventually there'll be enough water in that box which will make that ball become buoyant. The buoyancy will overcome the power of the vacuum, and literally the water is then just drawn out under vacuum and the ball sits down again. So very clever in its design, very simple in its operation. And I think it's key that you understand that it doesn't have to be a real Heath Robinson with all sorts of valves. It literally is. The appliance unit there, which we call the ball in the box, is as simple as it gets. Now, they do come in other shapes and sizes, depending on what you're going to deliver. Like that unit there, I wouldn't want to use that if you were delivering greasy water from a sink. If we were delivering greasy water from a sink, we use something more like the item you can see on the slide now. And it doesn't have to be from water from a sink. It doesn't have to be water from a basin or a bathroom or a kitchen. We can take any type of fluid, whether it be industrial, chemical, biological. We have all sorts of different projects that we've done over the years. So think outside the box. Anything where you need fluid moved and you can't use gravity because, or you need the design flexibility and the design benefits, then the vacuum system can work for you guys. The interface unit, like the vacuum toilets, again, no electrical power required to operate them. And it's not always one sanitary appliance to one interface unit. The picture you're seeing on the screen there was taken in a cinema toilet area, and you can just see, well, there are 6 basins there. One's just slightly out of shot. And all of those basins draining down to one interface unit that was positioned behind one of the panels in front of the wash basin there, with the riser going up to high level inside that orange force void there. So if you had a run of 6 basins, like we see there, going to one interface unit, if you had 2 basins, but they were on opposite sides of the room, then you may need 2 interface units. So it's all about flow rate rather than number of items. And like I just said there, we can take water from any type of liquid and from any type of fitting. So don't think it necessarily has to be bathroom or kitchen waste. We can go beyond that. So then finally, the third and final part of the system is the vacuum collection unit itself. And this is the only part of the system that needs any electrical power. and consisting of one collection tank, two what we call offline vacuum pumps, two discharge pumps, and the control panel. So we have two pumps. The system is designed to run on one pump, so you've got complete standby facility, 100% redundancy in the second pump there, which is actually a requirement of the EN standard. And we refer to these as offline pumps because no matter what sewage we get in the tank, none of the sewage passes through the pump. The pumps just remove the air from the tank only. So that's the only thing that goes through these pumps is air, not the sewage. And that means that because you're only turning air rather than turning sewage, you actually have rather a large power saving on that because it doesn't take as much energy to move air as it does sewage. Plus, the other thing is if you had an online pump and you have all those things that go into the tank that I told you about earlier, the towels, the clothing, it will get stuck in the vacuum pump and you will have to be doing a pit stop performance on it, taking the pump apart, removing it. So when you have air only going through the vacuum pump, you reduce your risk of failure hugely. Then we have our discharge pumps. The discharge pumps will kick in and empty the tank when the level switch is reached inside. They don't drain the tank right down to the bottom. So the reason for that, it keeps those pumps primed. And secondly, all of those foreign objects that I've mentioned about that do go down a vacuum system, because believe it or not, people do treat this as a waste disposal system. If we don't empty the tank completely, they stay in the tank, they don't get poured into the pump, and they're then removed during the maintenance times. And then we have our tank, and the tank is more just about storing water and discharging it. It's actually about storing vacuum. So when our tank is full of water, we're actually only at the halfway point in the tank. So we've always got a nice big reservoir of vacuum. So if you didn't have a vacuum tank there, the only vacuum storage you would have would be in your pipework. So if you were running a system like refer to a railway station again, where you have real impact use, what would happen is the first person would flush the toilet and the pump would then cut in to start to make vacuum. And while that pump was making vacuum, there wouldn't necessarily be enough vacuum in the system to flush the next toilet that's being flushed. So in a toilet system where you could have 5, 6, 7, 8 toilets flushed in a 1 minute period, you need a big supply of vacuum to be able to absorb that impact use. So that's the importance of having that tank, because what you don't want people to know is they're using a vacuum toilet system. You want people just to go in, use the toilet, flush it, and walk away again. And by not having the tank and by having relying on only your piping network to build up the vacuum, you will then get delays when flushing toilets. So we see it as a pretty critical part of the system. So the size of the tank, the discharge pumps and the vacuum pumps is something that will differ depending on the project. And that's something that's designed by ourselves here. So we'll take the information from you and then work out what size plant you need. It comes as a packaged piece of equipment, all simply controlled by the preloaded program in the control panel, where everything is displayed. It will give you your vacuum levels, it will give you the condition of the unit, it will bring up any alarms on that control panel, and will allow you to connect to your building's BMS system if required. So let's have a look at our system here. Here we are making vacuum, the water comes back into the tank, we get to the halfway point, like I said, and then it goes into discharge. Now, one thing perhaps I didn't explain to you guys earlier is the role of the vacuum pump there. Vacuum pumps don't run all the time. They run and create a level of vacuum. and the level of vacuum that it will make will depend on each individual project, how much vacuum we think is needed. Now, with positive pressure, you often hear people talk about 3 bar pressure, 5 bar pressure. With negative pressure, -1 bar is absolute vacuum. That's as far as the scale goes. So if I say to you that we're running a system at -0.5 of a bar, it doesn't sound an awful lot when you think about half a bar pressure of water compared to, say, 3 bar pressure of water. But it is 50% of what's available, 50% vacuum. So we will fine-tune the vacuum levels per project. So the vacuum pump will run and creates a vacuum level to whatever we've chosen to be, and the vacuum pump then switches off. So it's not running constantly. And as the system is used and the vacuum's diminished, then the pump's cut in. So if we look at, say, a hotel, for example, the plant will sit there throughout the night fairly idle, not doing too much. As soon as you get to around about 7 o'clock in the morning and people start to get up and start using the showers, flushing the toilets, the system becomes very busy. And then round about sort of 9 o'clock, then go quiet again. And then you'll see 10, 11, as the cleaners are going through the rooms, it starts to get used again, and then quiet down all afternoon as the rooms are changed over. So the pumps just run on demand as and when needed, not constantly. So, overview of the benefits of the system. I think the health and hygiene there I explained quite a few moments ago when I spoke about the hospital project. I think the key one for you guys here is this design flexibility to let you put things exactly where you want them, route around other obstacles and make the changes, and small bore piping, lifting up to a high level. All of these are huge design flexibility bonuses. I think we spoke about the construction and installation benefits. No vents. The only vent required on the vacuum system is the one that comes from the vacuum plant itself. No venting throughout the system. It's a closed system. No cisterns required. And from an environmental point of view, just 1.2 litres per flush, giving you large water savings. So just wanted to mention something else to you that Evac offer as well, our dry waste system. So we've spoken about our wet waste systems with sewage, but we actually offer a food waste system as well, where it will allow staff in restaurants to be able to tip food waste from prep areas, what's left on plates, into a macerating unit and be sent down to a collection plant. So think of the macerating unit almost like a toilet. The collection unit down in basement is exactly the same as our vacuum plant, but rather than receiving sewage, it's receiving a slurry waste. And we can see an example here. Now, whilst that looks like on the visual there, that would actually be great.
Steve, we've lost you there a bit. You're dropping in and out.
So, why would you want to use a vacuum food waste system? Well, we've actually just done our very first one in the UK, and it's just being commissioned at the moment. And I've got a slide in a few moments that explains where that comes up and the benefits of that. But a big advantage of it means that the food waste collected can be environmentally disposed or reused as biofuels. And just to give you some idea of the cost savings, it's around about £80-90 to send a tonne of waste to landfill. To send the waste to a bio unit is around about 10%, around about £8 or £9 a tonne. So you can see there's actually a pretty good payback for a client in using it. So, as far as us and the company is concerned, one of the things that I don't want anyone to be frightened of is when they think they might have a building that where they could utilise vacuum system, is being filled there, lumbered with having to come up with it and design it. We have a design tool. I take all of the information from you guys that you can give me on flow rates, expected use. I feed that all into our design tool, and that comes up with all the information I need to be able to size the tank, the pumps and the pipe work, and the amount of interface units we need. So I take all that away from you. The only thing I can't do is actually coordinate the pipe work, but you guys would be doing that anyway. During installation, we provide an on-site project management, so it's not just dumped to the contractor. We have registered installers that put this system in, and we're on site during that time offering project management. And at the end of a project, we then go on and we commission it. We're commissioning our equipment, but we're also commissioning the installer's pipe work, make sure fittings haven't been put down, your bends pointing, not bends, but branches pointing in the wrong direction, non-return valves the wrong way around. So everything's fully test commissioned, and at that point the warranty starts. Post-installation, again, we don't leave the client alone with this. We're offering a varied amount of support, telephone support, service plans, reactive call-outs. We work with a partner company that gives nationwide coverage and fast reactive call-outs, if needed, to any of the sites that we have around the country. And here in our office down in Kent, we have a huge range of spare parts that are available next day, same day if necessary, so we don't have to wait for a part to come in from abroad if needed. So that's part of our design promise. So these last 4 or 5 slides now, I just want to talk to you about some of the projects that we've done just in the last few moments. Some of these you'll know. Heathrow T5, built in 2005-2006. All of the first class lounge area and washroom facilities are fitted with the Evac system there. They'd had a major problem on a previous terminal where they'd had some leaks from toilet areas down onto some unclaimed baggage below, or the baggage reclaim area. And it was decided that the bathrooms in T5 again would be above the baggage reclaim area. And one of the things about a vacuum system is if you get a hole in a pipe, you don't get water leak out, you actually get air leak in. So by using the vacuum system here with the design benefits, the flexibility and the water saving were all add-on benefits. They've actually used it from a sort of design safety point of view. St Pancras Station, I've referred to railway station quite a lot when I've been talking to you. I mean, we've done this one, King's Cross over the road, Blackfriars Station, all on vacuum. I don't think it's a railway station myself. I think it's a shopping centre that trains happen to come into. And all of the retail units and all of the toilets, bar one block in the station there, are served by vacuum. And we'll take you back. I can't use gravity because there's an underground station underneath me, and I can't dig down and put all of this drainage